Lakehouse Federation allows you to query data from external sources without needing to ingest it into the Lakehouse. You can easily break down silos like the ones seen on the screen, and you can make them accessible on the data intelligence platform as a catalogs. Currently, there are 9 data sources available. That sources are Synapse, Redshift, Snowflake, Google BigQuery, Salesforce Data Cloud, MySQL, PostgreSQL, Microsoft SQL. Also, you can federate another Unity catalog. Soon, also Teradata and Oracle will join the club. With Lakehouse Federation, you gain unified view of all your data inside the Unity catalog. Unity catalog acts as an enterprise data catalog where you can manage permission, view lineage. From Unity catalog, you send real-time queries to analyze data or queries for machine learning purposes, and you don't need to move data to make these analytic queries. Lakehouse Federation uses the power of distributing computing of Spark. It leverages SQL Warehouse. SQL Warehouse optimizes queries which are pushed down to external data sources. So for example, if you use a filter, only the data which is needed will be imported from that database. So we can see here an example with filter where, for example, ID is equal to 1, and that filter is pushed down to external data sources. The same is about aggregation. Aggregation are also pushed down to external data sources. Additionally, you can delta share that data from Lakehouse Federation without SiteWord without ingesting this into the Lakehouse, and this is a really interesting use case. Okay, let's see in practice how Lakehouse Federation works. Let's look to scenario where both Azure SQL Database and Databricks are hosted in the same tenant. I will show you how to analyze data directly from Azure SQL using Databricks without ingesting that data into a data lake. We have Azure SQL Database, that one, and it's containing sales schema and product table. Let's make it available in Databricks. First, what we need to do in Databricks is create connection. To create connection, you need to have permissions which in Unity catalog, which is called create connection. And to do that, we click, it can be done programmatically or through UI. Let's click here, add connection. From connection type, let's select SQL Server. It's supporting also Azure SQL. So let's name connection Azure SQL. We are using simple setup, username and password, but probably for production purposes you will use OAuth, authentication with service principal, and set private link connection, but for now we are just using username and password. So we need to copy paste our host name. Okay, username is correct. I will copy the password. And let's test connection. It is using SQL Warehouse for connection purposes. Okay, connection established, perfect. Let's create it. We see here details about our connection. Inside our connection there is option to create catalog, so let's click it. We have to name it catalog. It is a name which will be used inside Databricks, and we need to choose which database from Azure SQL will be mapped to our catalog name in Databricks. In that case, the database name is SQL Hubert. Okay, let's copy that. So that SQL Hubert will be mapped to Azure SQL name, and schemas inside SQL Hubert will become databases inside our catalog. Okay, let's create it. We can configure catalog. So we said that all workspace have access to it. We can grant additional permission. The basic permission browse allow users to see what tables are there without seeing actual data. And save it. And that's all. And we have Azure SQL catalog here. Okay, and here is our Azure SQL catalog. So this is our database map to catalog. In that catalog, all users have browse permissions. We can grant also users use catalog permission. And for catalog which we are going to use sales, we will grant users use schema permissions. And for our product table, we will grant users select permissions. That catalog is read-only. That's why number of permissions is so limited. All catalogs under Lakehouse Federation are read-only. Okay, so we have product table. We can see some sample data. Yes, it is here, but let's see the same using SQL editor. So we will create query with that table. Okay, so let's build the query and check the push down filtering. So let's set that where product ID is equal to 710 and let's put limit 1. And let's execute that query. Okay, so we have our record. Let's see the time, how long it took to execute that. And when we click that, we can see query profile. And here, when we click this scanning of Lakehouse federated table, we can see exactly what query was sent to Azure SQL. So we can see that there was limit 1 was applied and that also our filter was applied. So only data which is needed was imported. But okay, let's see something more advanced and let's join that table with table which is already ingested into the Lakehouse. So that table is called product category and it should be joined on product category ID field. Okay, it worked, and to our product table from Azure SQL, category name was added. We can rename it to as category name. We can see the query profile, so we can see that the data which was read from Azure SQL was joined with data from Delta files, so from our Unity catalog table. And if we are going to use that query frequently, the good idea can be register that query as materialized view. So to do that, let's prettify it a bit and add here also a schema catalog and schema name. And what we need to do here, we will create materialized view. And we can name it, for example, external products. There are more options available for materialized view. For example, you can set scheduling for them, how often they are refreshed. But let's create the most simple one, which is only refreshed manually. Once our materialized view was created, we can find it in catalog. So we need to go to schema to which we save it. We can see it here. When we click, we can see when last time it was refreshed. When we click it, we'll open Delta Life table. So it is Delta Life table which is performing refreshing of that materialized view. What is interesting here is lineage tab, because if we click see lineage graph, we can see that our external data source, so SQL Server, is included in that lineage. So it's a really nice solution to govern your data and to check what is data flow. Additionally, we can create Delta share with that materialized view. It is possible also to share data from Lakehouse Federation without creating materialized view, but this feature is in private preview. So to try it, to share it directly, you need to contact your Databricks representative to enable it for your workspace. One thing which we need to remember is that depends on data source. For Lakehouse Federation, there are different data type mapping. You can check it in the documentation every time. So every data type from the source is mapped to different data type on Databricks side. And also there are always some information related to supported pushdowns. So it depends on data sources, there are more or less supported pushdowns. I think that Lakehouse Federation is a powerful tool to unlock numerous use cases, and I highly recommend you to explore its potential. Thank you for watching, and don't forget to subscribe to our channel. See you in the next video.